What's power series representation of different types of functions? First of all, recall the definition of a power series. We define a power series with center at A as the summation of Cn x minus a to power n, and start from 0, goes to infinity, and we can write this guy in expanded form as well as c sub 0 plus c sub 1, x minus a plus c sub 2, x minus a squared, and so on. When a is equal to 0, when the center is located at the origin, the power series is represented as Cn x to power n, and start from 0 goes to infinity, which is c sub 0, c1x, c2x squared, plus the rest of the terms. Remind yourself of geometric series. A geometric series was in general defined as the summation of a times r to power n minus 1, and started from 1, goes to infinity. And in a special case of power series representing geometric series, if you have the summation of x to power n, in this case, your ratio is equal to x, right? So this guy can be written as when n is equal to 0 and goes to infinity. This is x to power 0 plus x to the first power, x to the second power, dot, dot, dot. Again, from geometric series, if the absolute value of ratio is less than 1, this series is convergent to a divided by 1 minus r. So here you can say that as long as your x is less than 1 more than -1, or absolute value of x is less than 1, this series is convergent to 1 divided by 1 minus ratio, which is x. So what's happening here? You're basically having a power series x to the n, and this x to the n, as long as absolute value of x is less than 1, is convergent to this rational function. So this is our observation. The power series, the summation of x to the n, and start from 0 to infinity, which is 1 plus x squared plus dot, 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 is convergent to function f of x, 1 divided by 1 minus x, as long as absolute value of x is less than 1. Okay, but what's the meaning of this? It means that I can approximate this rational function using the summation of polynomials. It means that we can approximate the function f of x equals to 1 divided by 1 minus x by the sum of polynomials as long as absolute value of x is less than 1, or x is bounded between -1 and 1. Let us take a look at Desmos and see what's happening here. Let me open up Desmos for you. And go to our page. So first of all, our function is 1 divided by 1 minus x. This is the behavior of this function, and around x between -1 and 1, you see the behavior of the function up here. Down here, we are not really worried about it because x equals to 1 is the vertical asymptote. So you're basically taking this piece of the graph. Okay, the very first polynomial was 1 plus x, just a line. The second one, 1 plus x squared. Okay, now 1 plus x squared plus x cubed. You can add more terms to these polynomials. Plus x squared plus x cubed plus x to the 4th. Okay, it's getting closer and closer to the graph of 1 divided by 1 minus x. You can continue this process and see how you can use approximation to approximate basically functions using the sum of polynomials. X to the 4th plus x to the 5th. You can add more, x to the 6th, x to the 7th, plus x to the 8th. So if you just ignore these, as you increase the number of polynomials, you get a better approximation for this graph around -1 and 1. That's the whole point of representing functions using power series. As long as you can find an interval of convergence and find that function, you can basically approximate any function. We have some conditions, later we talk about it, and use power series to represent those complicated functions.